Okay, we're now going to talk about the second kind of equation problem. This one is one in which you have the reactants, but you do not have the products. So you have to determine the products. Because the same question, find the NetIonic equation and the spectator ions associated with this equation. So the first thing we got to do is try to figure out the charges associated with each of the elements in this compound, because they will determine the final products on the product side. So the first thing we do is we have to assign charges. Well, you're all familiar with the Criss Cross. When you have different number of substituents in your compound. If you don't remember your Criss Crosses, go to the polyatomic ion table and then you can work backwards, because you know the net charge on here has got to be 0. So I'm using the Criss Cross, and what I mean by the Criss Cross, we go from here to here and we look at this substituent, and if this is 2, this charge is going to be 2 on lead. There's only a 1 here implicit, which means the charge on NO3 is -1. Same thing here. 3 means +3, means iron is going to be +3. This means it's going to be -2, and look, that's how it looks in the final version. Now, the second thing you need to do is recognize this is a double displacement reaction. What does that mean? The positive in this is going to go with the negative here. The positive in this is going to go with the negative here. It's like just switching partners in a dance. And what it's going to look like is going to depend on the charges, and that's why we had to know the charges ahead of time. So now we do this and we get lead sulfate. Why? +2, -2. We get iron, and this is going to be a 3 because iron is +3. NO3 from this is a -1, so we get FeNO3, 3. Now we need to balance the equation. We all know how to balance equations, so I'll just get to the final answer, which is going to be 3PbNO3, 2 aqueous. And this, again, we are not sure what this is. We have to determine this is going to be solid or it's going to be aqueous. So over here we know it's aqueous because that's given in the problem. Now we go to step 3, which is check your solubility tables. Determine the status of new compounds. Every chemistry book has a different type of solubility table, so I can't tell you which rules to follow except to say read your solubility table, start with rule 1, go all the way down to the appropriate rule, and when you do that you find that this is going to be a solid and this is going to be aqueous, which means it's going to be in solution. Now we create the ionic. All the ionic is splitting these ones that are aqueous into halves. So this becomes 3pp + 2 aqueous, 3 times 2, 6NO3 minus aqueous, 2Fe + 3, 3SO4 minus 2. Then on the right side, because this is a solid, it doesn't break up, but this breaks up into 2Fe + 3 aqueous, 2 times 3, 6NO3 minus. This is the ionic equation. Now the NetIonic, as we've shown from the last one, is going to be all the ions that do not cancel out, which leaves us with Pb + 2 and SO4 and this. And again, so you understand what I'm talking about, these cancel, and that's how you get this, and that's why these are the spectators.